Darian Giuseppe here, guys, back again with another video for the Key Concept series. In this video, what we are going to look at is integration by parts. Where integration by parts is concerned, what we need to know is when do we use integration by parts, one, and two, we need to look at the formula for integration by parts. So those would be the two things, knowing when to use it, the formula, and we'll look at a simple example utilizing the formula for integration by parts, because you need to understand how to utilize it as well. So let's consider a function y is equal to x by e to the x. Because this function, right, is one function of x multiplied by another function of x, right? If you look at it, x is a function of x, obviously, and e to the x is a function of x as well. If we were to be asked to find the integral of this function y, which is equal to x by e to the x, if you look at it carefully and recall any of the recognition rules of integration, you would realize that it's very difficult. It have no recognition rules for that thing there, right? For this here. So, right, or because they are asking us to find the integral of a product of two functions, we would need to employ integration by parts and use the integration by parts formula. We need to know what is that formula. That formula is this here. And this formula is actually derived from the product rule formula for differentiation. So this is the formula here. This is your setup, right? This is the formula. You need to learn your formula. Cool, great. The next thing we need to know where the formula is concerned is we need to know what we let in be our u and our dv on dx. That's this here, right? From this, we need to try to figure out which one of them we want to be u and which one we want to be dv on dx. If you could see here, I let u be x and dv on dx, I let dv on dx be equal to e to the x. How do we determine which one? You might say, well, I could also let e to the x be u, and I could let this x be dv on dx. But what I like to say is, I always like to let the function that could be integrated easily be dv on dx. That's what I like to say. Because after you put this line, we have to differentiate this and we have to integrate this. So my take on it is always put the function that is easily integrated to be dv on dx. Or you can use the LIAT rule that persons like to use as well. So this is the acronym, right, LIAT. What the L stands for is log functions, I stands for inverse functions, A stands for algebraic functions, T stands for trig functions, and E stands for exponential functions. The whole purpose of this, it helps us to know which function to let u be, right? So what you would need to utilize this, you need to look at the product of the two functions that you need to find the integral of, right? You need to look at the product of the two functions that you need to find the integral of. And let's use this in this example here. Let's use the LIAT rule. Let's use the LIAT rule on this here. So we would notice that x is an algebraic function and e to the x is exponential. So what the LIAT rule says is the higher up the function is, the greater, what's the word I'm looking for? The greater precedence or the greater preference it is given to let it be equal to u. That is what I'm saying. So because x is algebraic, and algebraic in the LIAT acronym is found before E exponential, the algebraic, right, function, which is x, would gain preference to be u. And therefore, right, you know, as a result of that, dv on dx has to be e to the x. So that's the Iliad rule, right? You look at the two functions, and wherever the function is, the position it is, right? The ones higher above, they would have preference in u, right? And the other function would obviously have to go in the dv on dx. That's basically it. But for me personally, I just say whichever of the two functions is easiest to integrate, I let dv on dx be equal to it. That's basically it, right? So that is the explanation. This is very important. You want to make sure and do that correctly, right? Setting the right function for u and dv on dx could actually determine whether or not you get the integral right or wrong, or how fast you get the integral. That's basically it. It will help you determine how fast, right? So you want to choose the correct values or the correct functions to be u and dv on dx, so that you wouldn't waste too much time. So I think I talk about this a little bit too much, but it is very important. So the next thing we need to do is differentiate du and then differentiate the dv on dx. So when we differentiate du, we get, right, the differential of x, which is 1, and the integral of e to the x, we have to integrate this, is e to the x. So you see, it's simple to integrate, so that's why we use that. And now, right, all we need to do now is take this guy, the v, and multiply it by the u, straight from the formula, right? And then take the v and multiply it by the du on dx, straight from the formula, right? And just put all these things together, right? Remember, the initial integral was the integral of x by e to the x dx. That is what we want to find, right? So this is the integral. This is the function y. So we wanted to find the integral of that, the product of two functions. Remember, that's what we're trying to do. And that's what integration by parts helps us to do. And this is your v by u here, and your v by du on dx here. And then we just integrate e to the x. The integral of e to the x is what? E to the x. So this very simple, but e to the x plus c. Do not forget your constant of integration. So in the end, the integral of this function, right, where we have the product of two functions, right, of x, is this here, x by e to the x minus e to the x plus c. So the integral of x by e to the x with respect to dx is equal to this. Don't forget your constant of integration. And that's basically it with regards to integration by parts. Guys, we want to make sure we understand when to use integration by parts, right? Whenever, and that is whenever you have, or you are asked to find the integral of the product of two functions of x. That's when you use it. We want to make sure that we learn off the formula for integration by parts, and we want to make sure we can apply the formula correctly. That is key, right? So those are the key points, right, that I deem important where integration by parts is concerned, guys. Feel free to like the video, share it to a friend that you believe it will be helpful to. And with that said, see you in the next video.